Hey guys, this is JB Mon from Tendencies Tutoring. Today we're going to be discussing derivatives, which is a topic in differential calculus. Don't forget to use my referral code JBMon20 to receive 10% off on your next tutoring package. So calculus, let's just start off by defining calculus. Calculus, it's pretty much a tool that's used by a variety of fields to find the most optimal solution for certain problems, certain complex problems. It was invented independently by Newton and Leibniz in the late 1600s. And it can be subdivided into two different categories. So calculus can be subdivided into two different topics: differential calculus and integral calculus. So differential calculus pretty much focuses on the rates at which quantities change. It's more or less focused on slopes and other sorts of rates and stuff, whereas integral mainly focuses on the area underneath the curve. So in other words, differential, it kind of just focuses on the derivatives, which I'm gonna just get to, it's another word. A derivative is just another word for a slope. All right. So how do we solve for a slope on a linear function? Well, if you have a linear function, all we really do is we draw up the linear function and we do the change in y over the change in x. In other words, we measure out if we have a point right here and a point right here. If you have the coordinate value there, and let's label that to be coordinates x1, y1, and x2, y2. The slope of this line would just be the change in the y direction, which would just be y2 minus y1 over x2 minus x1. And this is true for all linear graphs. And so another way to just write this down is it's the change in x, or it's the change in y divided by the change in x, or in terms of Greek letters, it's equal to delta y over delta x. This is the Greek letter delta, which is another word just saying change in y. y2 minus y1, change in y, all the same thing. All right. Now that we know how to solve for a linear graph, how do we solve for example, the slope of a more complex graph? Let's say a quadratic. Just the rest. All right, anyway, let's just focus on the right side of this graph. So we have a quadratic graph right here. Let's say this is equal to the equation y is equal to x squared. Well, how can we find the slope here? Well, as we can see, the slope at the bottom is not the same as the top slope on the right, which is not the same as the slope on the left. On the left, we have a very negative, a decreasing slope, whereas on the bottom, an increasing slope that's becoming more positive. It's negative and then it becomes more positive, but it still becomes smaller in magnitude. Then on the towards the center of the graph, or towards the origin, we have a slope which is about 0. And then right about here, it just keeps on increasing, which eventually becomes a very high number. Well, how can we find the slope of this quadratic equation? Well, the best way, or the easiest way from what we know, is by probably just finding the slope at two different points. As we can see, since there are different slopes, if you're trying to find the slope at, let's say, this point right here, that's pretty much, you can make like a tangent line straight through it, which would have the exact same slope at that point. Well, we can't really make a tangent line without having more details about this graph. So another way we can do this is by pointing two different points on a graph and trying to make an approximate line, or an approximate line between them. And we can now use the change in y minus the change in y divided by change in x formula to figure out the slope between them. And that would approximately be the slope right here. So let's say that this is, so let's say that this point right here is at point x1. Actually, let's call it point A. And let's call this point f of A. And let's call the second point A plus H. And let's call the second point f of A plus H. It's A plus H because it's just shifted to the right by a distance of H. All right, so, well, how can we write down the slope? It's just going to be, the slope right here would just be f of A plus H minus, this is y2, f of A, which is y1, divided by A plus H minus A. Well, these two A's would cancel each other out, and we would be left with f of A plus H minus f of A divided by H. All right, so this function right here pretty much, or this equation right here, this expression pretty much gives you the slope, the equivalent of the slope, or an approximation of the slope at this point right here. Well, how can we make this approximation a little bit better? Well, what if we just make this H value a lot smaller? The smaller the H value, let's say the H value is over there, the closer it is to being the exact slope. The further away it is, it's less and less likely to be the actual slope. So as long as the slope becomes as close as possible to the original point, which is at f of A, then in that case, we would be able to get a very approximate, or a very close, a very good approximation for the slope itself. So in this case, we would just have to make the limit as h approaches 0. Remember, a limit as h approaches 0 does not mean when h is equal to 0. If we set h equal to 0, then this function is undefined. There's no solution to that. Well, as h approaches 0, we are going to notice that we have a proper slope over here. Well then, we kind of just defined that f prime of x I'm just substituting in the a with an x. So we kind of just proven that the slope of a function, f prime, let's say f of x, which is going to be f prime of x, is equal to, as you can see, the function of x plus h minus f of a divided by h. X plus h minus f of x divided by h. And this approximation gets, as I mentioned, closer and closer as we approach a 0 for h. Well then, why not try using this formula to solve for the slope of this function right here. If we have a function 3x squared minus 4x plus 2, how can we solve for the derivative of that function? Well, we have the f of x value, which is going to be 3x squared minus 4x plus 2. And now we would just be trying to plug in that f of x value into the f of x plus h minus f of x divided by h all over h equation to solve for what f prime of x would be. If we try doing that, we would have f prime of x is equal to f of x, or f of x plus h, which is equal to 3x plus h squared minus 4 times x plus h plus 2. This is going to be f of x plus h minus f of x, which is just going to be 3x squared minus 4x plus 2. 3x squared minus 4x plus 2 all over h. Well, right here we can cancel out the plus 2's, and 3 times x plus h squared. Well, if you use perfect square trinomial, we would be able to state that this value right here, x plus h squared, that's just equal to x squared plus 2xh plus h squared. And let's multiply that out by the 3, and we would get 3x squared plus 6xh plus h squared. Let's distribute out the negative 4. We get negative 4x minus 4h minus 3x squared minus 4x divided by h. The limit as h approaches 0. The limit as h approaches 0. Well, this right here, we can cancel out the 3x squared terms right here, the negative 4x terms right here, and we would pretty much have a simplified answer. This is equal to the limit as h approaches 0 of, there is no 3 term, 6xh plus h squared minus 4h divided by h. Well, we can actually just divide out the h's, and this would simply simplify down to the limit as h approaches 0 of 6h, or 6x plus h minus 4, which if we plug in 0 for h, we get 6x minus 4. In other words, at any point on the graph, we would have a slope of 6x minus 4 for the function 3x squared minus 4x plus 2. If we go back to the quadratic equation, let's say that we had a point at 1, 1. So let's say that's 1, 1. And let's say we had another point at 3, 9. If we tried plugging in the values right here, we would be getting f of 1, which is 1, and f of 1 plus the distance to 3, which is just 2, which is going to be, well, that's just equal to 2. 1 plus 2 is equal to 3. So f of 1 plus 2 is equal to, which is f of 3, is just equal to 9. So that's going to be 9 minus 1 divided by, well, 2. And that's going to be the average slope right here. But that is not necessarily the slope at every one of these points. It's going to be different. And that's what a simplified expression itself would give you. So if you tried solving for this equation itself, the slope for this problem, it would be let's say the f of x is equal to x squared. In that case, we would just have f of x plus h, which is just equal to x plus h squared minus x squared divided by h. And from here, all we need to really do is just solve out this polynomial right here. I mean, this perfect square trinomial, and you'd get x squared plus 2xh plus h squared plus h squared, and you'd be subtracting out x squared and dividing it out by h. X squares cancel each other out, and the h's cancel right here. And now you're left with, which is equal, and now you're left with limit as h approaches 0 of 2x plus h, which is just equal to 2x. Because when you plug in 0 for h, you get 0, or you get 2x. All right. So here are some of the different kinds of rules that we can follow along for the derivatives. So if you have a constant represented by c, multiplied by a function. So let y be f of x and let z be a different function g of x. So if we have a constant multiplied by a function and we're getting its derivative, so let's say maybe 6 times x squared. The derivative here would just be the derivative of the x squared value, which we already found to be 2x, times c, which is the constant. So this would just be 12x. If we have two different functions, at y be f of x and z be g of x, and we're trying to find the derivative of their sum, or actually their difference as well. You can just differentiate it with a minus sign. You would be able to do f of x the derivative of f of x plus the derivative of g of x, which if you're looking at the first problem, or the two problems that we already done, so f of x is equal to x squared, and f of x is equal to 3x squared minus 4x plus 2, well, we would be able to get 2x plus, I'm only doing the positive, 3x minus 4, which simplifies down to, well, if you combine those two terms, those two like terms, we get 5x plus 4. Now, if we try, now if we try doing the derivative of y times z prime, this is called the product rule. The product rule. We would just be multiplying out the function y times the derivative of z, and then adding the derivative of y with the multiplied by z. Now, if you're doing the quotient rule instead, which is when you're just dividing it out, this is going to be called the quotient rule. The quotient rule, we would just be multiplying the z value, or whatever is on the bottom, the denominator, the function that's on the denominator, with the function on the top, the derivative of the function on the top, and then subtracting out the function on the top multiplied by the derivative of the function on the bottom, and then dividing it all by the function on the bottom squared. An easier way to remember this is by saying out low d high, low d high, low times the derivative of the high, minus high D low all over low low. And what does the low stand for? The low stands for the bottom function, and the high stands for the upper function. Some constant ones to remember is, well, the derivative of a constant is just always equal to 0. And I mean, if you look at it, if you look at a function, or if you look at a graph for a constant, there is no change in slope, and that's why it's always equal to 0. The derivative of this is going to be called the power rule. The derivative of x to the power of n is always equal to n times x to the power of n minus 1, which we can see right here with the x squared. So x squared would be 2 times x to the power of 2 minus 1, which is just equal to 2 times x to the power of 1, and x to the power of 1 is just equal to x, so it's just equal to 2x, which is exactly what we got in the problem. And finally, we have one last rule to follow, and that's called the chain rule. The chain rule pretty much just states that if you have a function within another function, you're trying to figure out the derivative of that new function. So you're taking the derivative of f of g of x. That would just be equal to f prime of g of x times g prime of x. Right. This is pretty much all there is for this session. Thank you all for watching. See you next time.